Okay, so we have 5 inches above the table, which we said was our vertical height. So we're going to plug that in for V of H. So my new equation is 5 equals 4/5 times the absolute value of H minus 10. And it's very similar. Yes, it just has some more fractions on it, or less fractions still. But I have 5 equals 4/5 times H minus 10, the absolute value of H minus 10. And what we talked about on Friday was that if we have the absolute value of something in the problem, we are trying to isolate the absolute value symbol. We're trying to get that by itself. So I don't need to distribute the 4/5 in. I need to get rid of that 4/5. How do I get rid of it? Mathematically, what do? I'm going to multiply by 5/4. I'm going to divide by 4/5. They are the same thing. Okay, if you're typing that in the calculator, 5 divided by 4/5, make sure you put that 4/5 in the parentheses or use the fancy fraction just to kind of make sure that you get that right. Or mathematically, the same thing would happen if I did 5 times 5/4. And 5 times 5/4, I think that gives me 6.25. Someone in first grade told me the answer. Was it 6.25? Okay. So 6.25 equals the absolute value of H minus 10. Okay, 6.25 equals the absolute value of H minus 10. So once my absolute value symbol is isolated and I need to start solving, what do? No. I have to first split it as 2. I have to get rid of my absolute value symbols by writing it as 2 problems. My first problem being H minus 10 equals 6.25, and my second problem being H minus 10 equals what? Negative 6.25. Because remember, what's inside the absolute value symbols, which in this case is my H minus 10, can either be positive or it can be negative. Okay, what is inside the absolute value symbols can be positive or negative. It's going to work out no matter what. Okay, it can be positive or negative. So, mathematically, how do I solve this? What do I do to get rid of this minus 10? Add 10. And what is 6.25 plus 10? Okay, so H equals 16.25. And that would be my first answer. Okay, then what do I do to find the second answer? Add 10. Okay, what is negative 6.25 plus 10? Thank you for not saying negative 4.25. So I have 2 answers. Does it make sense that there are 2 answers to this problem? Yeah. Why? Why does it make sense that you have 2 answers to this problem? Okay, how high was the actual laser above the table?
8.
It was 8. And we're looking for when the beam is 8 inches above, or 5 inches above, sorry. It's like imagine like there's a line drawn here, that this would be like my 5 inches above. So that happens twice. It happens like before it reflects and then after it reflects. So there should be 2 solutions, 2 points where the beam is 5 inches above. Yes, ma'am, you look confused. Okay. It depends on the angle, like when that happens, but it does happen eventually. Yes, ma'am.
So, like, if you were solving for when the beam was 12 inches off the table, you would have 1 answer?
Yes, if you were solving for when it was 12 inches off the table, there would only be 1 solution because it doesn't start out at 12, it starts out below that. So it would be the far point over there. Yes, ma'am.
So if this equation is going like that,
Yes.
if the y was 5, goes where it is.
Say that again, I'm sorry.
If the y was 5,
Mm-hmm.
and those 2 points are where it is.
Yes, that's exactly what it is. All right, so we're looking at problem 25 on the homework, which is on the supplemental material. Okay, it's on the little half sheet that you just got. I don't want you to write yet. Okay, I will tell you guys when to write, so just give me a second. So when you look at this problem, how is this problem different than all the problems that we did on Friday? They're both absolute values. So what we learned, like when we did absolute values, like if we had, again, we're not writing yet, I'll tell you when to write. If you had something like the absolute value of 2x plus 1 equals 4, then we wrote that as two problems. We wrote that as 2x plus 1 equals 4, and we wrote that as 2x plus 1 equals negative 4. So there was two forms. So we took what was inside and we made it equal to the positive form, and we took what was inside and we made it equal to the negative form. Again, we're not writing yet. I'll tell you when you can start writing. Okay? So our problem is different in that our problem has two absolute value symbols. So we have to apply that same logic to answer this question. So what this means for us is it means that there are actually, and again, we're not writing yet. You are not writing it. I will tell you when to start writing. Okay? I promise I'll tell you. There's actually 4 possibilities for this problem. The first one, and this one will make sense, is that easily 5x plus 3 should equal 2x minus 1. That makes sense. Again, we're not writing it. I'll tell you when to start writing. So we're saying what's inside should equal what's inside. That would make sense. In order for these two things to be the same, then 5x plus 3 should equal 2x minus 1. Well, normally, if we didn't have an absolute value symbol over here, what would our next option be? Close. We would have, our second option would be that 5x plus 3 equals the negative of 2x minus 1. So the opposite of the entire thing, not just part of it, the whole thing. Again, we're not writing yet. I'll tell you when to start writing. Okay, so that takes care of like switching the sign for this absolute value symbol, the 2x minus 1 here. Okay, but what else do you think might be another possibility? Okay, so if I had the negative of 5x minus 3 equal to 2x minus 1, sorry, plus 3, yes, equal to 2x minus 1. Or what do you think our fourth option is?
All of it is the opposite.
Yes, all of it is the opposite sign. So that fourth option, again, we're not writing yet, is negative 5x plus 3 equals negative of 2x minus 1. So in option 1, they're both positive. Option 1, 1 positive, 1 negative. Option 2, 1 negative, 1 positive. Option 3, they're both negative. Seems like a lot of work, doesn't it? But what? A little bit. Oh, I thought you said but what? Okay. I'm going to tell you that it's not as much work as it seems. Because if I take the negative of both sides of my equation, and let's suppose that I divided by negative 1, because I can do that. I can do whatever I want to one side of an equation as long as I do it to the other. What happens here when I divide a negative by a negative? They're both going to turn positive. So really, this one down here in the bottom right is the exact same thing as 5x plus 3 equals 2x minus 1.
Yeah, but that was.
These are actually the exact, algebraically, they're going to work out to be the exact same thing. Because the only difference between the first problem and the fourth problem is that you multiply the entire first one by negative 1. It's not going to give you a different answer. What is also true is that 5x plus 3 equals the negative of 2x minus 1 is the exact same thing as the negative of 5x plus 3 equals 2x minus 1. And when I say it's the same thing, I mean they're going to work out equivalent. Okay? If you were to work them out, they would give you the same answer. So we don't have to do this 4 times. We only have to do it twice. Okay? So again, our problem, and you can start writing now. Our problem was the absolute value of 5x minus 3 plus 3, thank you, equals the absolute value of 2x minus 1. And so we are going to do 2 problems here. Our first problem is simple, that 5x plus 3 equals 2x minus 1. And that makes sense, because if we have 2 things that are equal, like the absolute value of 2 things are equal, then what's inside of those absolute value symbols should be equal to each other. Our second problem that we are going to work out is that 5x plus 3 is going to equal the negative form of 2x minus 1, which is the opposite form. And this is going back to our idea of absolute value. What's inside the absolute value can be positive or negative, but when it comes out, it's always going to be positive. So what's inside can be the positive or the negative form of something. So then we worked them out and we solved them. These problems are a little more complicated than our problems from Friday. And like we just have to do a little bit more math, but they're not like difficult problems. Like this is basic solving equations for x from Algebra 1. So how do I solve this? What do I do algebraically to solve this? How? Okay, so I'm going to subtract 2x from both sides so that I can get my x's on the same side. So I have 3x plus 3 equals negative 1. Then what am I going to do? Subtract 3 from both sides. And I get 3x equals negative 4. And then what do? Divide by 3 and you get x equals negative 4 over 3. So that is one of your two possible answers. That is one of your two possible answers. So then to find our other answer, we work out the second part of it. So we have 5x plus 3 equals negative times 2x minus 1. What do I need to do to work this out? Okay, I need to distribute that negative, so I'm carrying it over to everything. So that's going to give me a negative 2x and a positive 1. And it still equals, I still have 5x plus 3 equals negative 2x plus 1. All right, same idea that I need to get the x's on one side, everything else on the other. So what do I need to move? The negative 2x, which I do that by adding 2x this time. So then I get 7x plus 3 equals 1. What do I do now? Do I? Yes. Okay, so I'm going to minus 3 from both sides. And I get 7x equals negative 2. And then divide by 7. So my second answer would be x equals, would be negative 2 over 7. So that's my two answers. Okay, here's why. Because I think seeing this graphically kind of helps make sense with our solutions. Oops. Not what I wanted to do.
Do we always put the second equation to be negative?
So we are going to look graphically at why this works, because I think that will help make sense. So we have 5x plus, the absolute value of 5x plus 3 equals the absolute value of 2x minus 1. Well, what do absolute values look like when we graph them? What shape do they take? They're a V. So we'll say that this one, we'll make that my red graph. So I'm going to have some red graph of 5x plus 3. Okay. And then what about 2x plus 1? What's that going to look like when I graph it? It's also going to be a V. I'm going to tell you this one's going to be a little bit wider. And the reason I know this one is wider is thinking back to the idea of like lines and slope. Because I have this 2 here, that 2 means my line's a little bit less steep than my 5 is. So this graph, that the 2x minus 1, is going to look something like this. So our graphs are going to intersect twice. What else could happen if I had absolute values on both sides? How else could they intersect? What else could happen? They could not intersect at all? How would they not intersect at all? What would happen? Okay, so one would have to be negative, one would have to be positive. They were reflected over the x-axis. So that's a possibility. So then you would have no solutions if they both looked like this. Okay, so when did we have no solutions? What happened? When we were looking at what we did on Friday, from what we did on Friday, when did it have no solution? Do y'all remember? It was when you had the absolute value of something equal to some negative number. Okay, that's when you had something that was no solution. Now, what would happen when you were, if you're looking at one where you have two absolute values in it, what will happen is all your x's will cancel out, but you'll end up with something weird like negative 3 equals 12. Negative 3 and 12 are not equal numbers, so that's going to imply that there is no solution there. So what else could happen if I had two absolute values graphed? How would they intersect once? Maybe they could share the vertex. One would open down. Let me do this one a different color. or they could be equal to each other. There's another way actually that two absolute values could have one solution.
Like if the vertex is on the side.
Kind of, if they're like, it's like almost that they're parallel. If you understand the idea of parallel means they like, in a way they don't touch. Like if you understand that each part is parallel to the other part. So those would have one solution, okay? So if it was like 2x plus 5 and then 2x minus 7, then they're going to be, in a way, parallel. They are going to intersect somewhere because it does go back up. But our lines, like if you look at this part as one line, like let me highlight here. If you look at this as one line and this is another line, they're parallel to each other. And then same thing is true with the other half. Those are parallel to each other. Yes, ma'am.
Could you have one like when we were doing parabolas and we had y squared if it was like that?
You could. None of the ones we will have that though. Okay? So this is a possibility for two absolute values as well. All right. So like if I had an absolute value, like if I had, for example, 3x plus 5, the absolute value of 3x plus 5 equals 0. Well, when we isolate the absolute value symbol, that's where we separate this out into two problems. And technically, my first problem is 3x plus 5 equals 0. Or my second problem is 3x plus 5 equals negative 0. But I don't actually have a concept of positive and negative 0. 0 is just 0. So algebraically, these are both going to work out to be the exact same thing. So you can have an absolute value equal to 0. What can you not have? An absolute value equal to something negative.
Oh wait, so if it does, you don't have to solve any further?
Yes, so if you have, for example, the absolute value of 2x plus 7 equals negative 13, that automatically has no solution. Because what you're saying is that when you take the absolute value of whatever this is, you're going to get something negative. And that's never true because when you take the absolute value of something, you're always going to get something that is positive every time. Okay? What other questions do you guys have?